So today in this video we're gonna talk about the node. Previously we have seen like what is the solution of Schrodinger wave equation. So here we're gonna talk about for orbit number of radial nodes is equals to n minus l minus 1 and number of angular node is equals to l, where l is the azimuthal quantum number, n is the principal quantum number, and total number of nodes is n minus 1. Total number of nodes means is talking with radial and angular node. If we sum both of them, we will be getting n minus 1. So that's how we calculate the number of node by using the quantum numbers. So now if we try to draw the curve, like if we want to draw the curve for 1s, for 1s electron, for 1s orbital, okay, one subshell. So what we're gonna do is r radial curve with the distance of r. So as we know, as s has a spherical shape, okay, so it do not have any okay, what will have the maximum probability of electron in maximum on the center, then it gonna decrease like this. Okay, so means it do not have any node. We can also check by the formula n minus 1. N minus 1 means it do not having node. Now what gonna do, we gonna like talk about 2s. When we gonna talk about 2s, what we gonna do, first there will be 1s electron, then there will be a node space, and there will be a 2s electron. So there is a node between 1s and 2s, so that is that node. Okay, we can find the distance, okay, where it is falling. Now that's how we could only draw the curve, and we could know where the node is. So here it is the node because it is the node empty space over there. Or we could also use the formula n minus 1 means one node is there. If we want to draw the curve 3s, so again from formula n minus 1 means 3 minus 1 equals to 2. It has two nodes because 1s electron is there, then 2s electron will be there, then 3s electron will be there. So there are 1, 2, 2 empty space are coming. So this is 1 and 2 empty space are coming, which are called as node. Similarly, in case of 4s, total number of node is n minus 1 means 4 minus 1, that is equals to 3. So 1, 2 and 3. That's how we gonna talk about there are three nodes. Okay, 3 nodes over here. So when there are 3 nodes, so that's how we will be drawing the curve r versus r. Okay. Now to find the position of electron where electron finding probability is 0, r equals to 0 and psi equals to 0. So to find the position of electron where electron having finding probability is 0. So when wave function changes its sign indicates position of radial node. So wave function is changing its sign. Wave function was positive here, negative here. So wave function actually changing its sign from positive to negative. So that empty space is known as node. When wave function changes its sign indicates position of radial node. So that indicates the position of radial node. Okay. So now let's talk about r square. When we are squaring the term, we are talking about the probability. Okay. So to find the position of electron where electron finding probability is 0. Okay. Now what we gonna do? We gonna same drawing the curve, but here it is time r square. R square means we are only talking the positive terms. I mean it will be automatically come the positive term from the graphs. So if we square the graph of like 1s, this is 1s graph. If we are squaring the graph, the graph will come again that hyperbola. Okay. So this type of hyperbola, the curve will be coming. Okay. Now if we talk about like r or versus r, so here the graph is of 2s. Now if it was not r square means the graph will be coming from downside and this, but when we are squaring the term, the graph will be come upside. Okay, so that's how the r square r curve is there. Now if we're talking about 3s, we are having 2 nodes in 3s, that's why the curve is coming like the upper side. And when we are talking about 4s, 1, 2, 3, 4s means node is n minus 1 means 4 minus 1 is equals to 3. 1, 2, 3, 3 nodes are there. Okay, now if we're talking about for the curve like 2p, 3d, 4f, 5g, 6h, radial node is 0. So we will be getting this type of curve when we are talking about like in the 2p, 3d, 4f, 5g, 6h. We know when radial node is 0, so when like 1s, okay, 1s we have seen. Similarly, these case radial node is 0. if we could find the formula n minus L minus 1, that is the formula of radial load. So every time we will put this formula, we will getting 0. So that's how there will be curve like this. And now again n minus L minus 1 radial load. Okay, if in radial load we are getting 1, let's say 4D. In case of 4D, n value is 4, L value is 2, and 1. So we are getting radial node 1. So that's type of curve we will getting from 3P, 4D, 5F, and 6G. And if we talk about like the when the 4P, 5D, 6F radial load is 2, this type of curve we will be getting. When radial load is 2, we know that there will be changing in sine wave function and we will be getting this node. So that's how when radial load is 2, again we will n minus L minus 1, the values are 2, that's that type of curve we will be getting radial load. Or R square versus R when 0 radial load, this type of curve will be there. And R square versus R when 1 radial load, there will be no negative sign, every time it will be positive. That's type of curve we will be getting. And R square versus R when 2 radial load it is there. So this type of curve we will be getting because we are having 2 radial load, 1 radial load, 2 radial load without changing its sign, because in terms of original curve R versus R, it was a negative sign and positive sign. But since we have squared the whole curve, so it will be always be giving a positive value. So that's how this type of curve we draw.